Okay, this is the last lesson of the conic section. Last lesson, and we are going to talk about hyperbolas, not to be confused with hyperbole, an exaggeration in English, I believe. Hyperbolas, okay? Again, pause this video. I've already rewritten the definitions and drawn some graphs and written the formulas, so pause at any time to write down the notes and then watch as I do 2 examples today. So a hyperbola is the set of all points in a plane in which the difference of the distances from 2 foci is constant. The differences from 2 foci is constant, okay? So you are going to have what looks like 2 parabolas, okay? You're going to find their vertices, each one. And each one has a foci. Each one has a foci. Now, what this definition is saying, just so you understand, oh, by the way, you also have to find a center point because they have to be, the vertices have to be the same distance from that center point. But the difference of the distance from this foci, you can see there's a glare there, from this foci to a point on the hyperbola over to this foci. Okay, and those differences is the same wherever I move it. And there's some cool like applets you can look at, and you can just start moving point P. See if I can, come on. And you can see their differences is constant. You can change it, make it a little bit wider of a hyperbola, make it a little bit tighter. And watch as you move around the hyperbola. Our planet, actually, a path of a spacecraft usually travels along the hyperbolic shape. So pretty neat indeed. All right, so these are the standard equations for the hyperbola. Should look familiar to you. X minus h squared over a squared minus y minus k squared over b squared equals 1. And then y minus k squared over a squared minus h squared over b squared equals 1. Interesting. What does this look like to you? It's the ellipse equation, except with a minus. That's all it is. It's the ellipse equation with a minus, okay? Now, here's where it's different, okay? Whichever side, whichever axis is positive, that is your major axis. So this is your major axis, which is positive. See, this is the x, it comes first. That's the positive. There's a minus here, minus this y squared. So the x-axis is our major axis for this one. Whereas if the y comes first and it's positive, that's the major axis, okay? It's not based off of which of these numbers is bigger. It is not, it is not, it is not. Are you listening? It is not based off of which of these is bigger. That's an ellipse. If this is bigger, then that's the major axis. If this one's bigger, then that's not how it is on a hyperbola. Whichever one is positive, that is my major axis. Get that in your head. Take that, put a big star around it, okay? Also, your foci equation is different. No longer is it c squared equals a squared minus b squared, but it's plus. And I just remember that if this is minus, this is plus. If this is plus, this is minus, okay? So if this is minus, this is our hyperbola, then this is plus. So these are your formulas and pictures. All right, let's, just before we start to graph, I want you to write this down. This is what we're going to be doing today. How to graph hyperbolas. First thing I want you to find is your center. Obviously, that's always a good place to start. And then we're going to find our A, our B, and our C. Now, this is where it gets a little tricky and a little strange. Instead, we're going to start drawing a rectangle around A and B. Then we draw in these asymptotes, which are the diagonals of a rectangle. And then we form our U's on the major axis, those hyperbola shapes, okay? Watch me do an example. We're going to actually do 2. And then hopefully this will make sense for you. Again, pause this to write this down. And then here we're going to do graph and label the following hyperbola. All right. So step number 1, find your center. Now, be careful. I've tricked you already with the first one. How did I trick you? Well, I'm going to change my pen here. Y plus 4 squared over 25 minus x minus 2 squared, okay, equals 1. So we know it's a hyperbola. Where's my center? Remember, center is HK. HK. H is always with the x. K is always with the y. So change their signs. 2, -4. 2, -4. Now, you can put a dot right now at 2, -4. Might as well. Right there. Then we are going to find our A and our B's. Now, I already know this is positive. So my major axis is y, and you can write that down if you want. It's not because this is bigger. It's because that is positive. That's what makes a hyperbola. So I know my U's are going to go, what do you think? Left and right or up and down? If my major axis is y. Up, down, okay? So I don't, again, I don't follow formulas. I go according to what's this. If 25 is under the y, then I go 5, I go the square root of this, I go 5 up and 5 down from the center. 5 up, 1, 2, 3, 4, 5, and 5 down, 1, 2, 3, 4, 5. I like counting. Now, if I'm under the x, I'm going to go left and right that direction. Left and right, the square root of 36. What's the square root of 36? 6. So I'm going to go left and right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, now if I've done that right, this should make a perfect rectangle. And that's what you're going to draw in right now. Drawing in my rectangle. Okay. From that rectangle, you are going to draw in diagonals of the rectangle. These are called asymptotes. We're going to draw in the diagonals of the rectangle and make them pretty long. So here's what I mean. You're going to go like this, right through the center. And we're going to extend it outside of the box. Okay. Now we're almost done with drawing, and then we just have to label our stuff. We just said before, where are my U's going to lie? Am I going to draw my U left and right or up and down? Well, I'm going to draw them according to which one's positive, which one's major, which is the Y. So I'm going to draw them up and down. So that's what these asymptotes do. They actually tell you how wide this picture is going to be. So you want it to go pretty wide. You want it to touch this point right here, not the center, this point right here, and then scoop away. And then the other one is going to touch this point right here, and then scoop away. And that is your perfectly drawn hyperbola. Now, let's label all the parts. We got our center, 2, -4. We need to label our 2 vertices. Your 2 vertices are where the hyperbolas touch at that point right there and right there. So this is the point 2, 1. And this one is the point 2, -9. I believe it's -9. All right, and then we are going to now find our foci. Our foci, remember, they're always caught. They're always caught. So foci, and foci this time uses a different formula. The formula for foci, again, would be c squared equals a squared plus b squared. If we had done minus here, you'll see what happens here. You would get a negative number, so it wouldn't work out. And does it matter which one you call your a squared and b squared? Not really, because you're just taking these two numbers and adding them. 36 and 25. And that'll be 61. And I know Mr. Belk likes to put plus or minus square root 61. That's fine. I'm just actually going to write it as a decimal because that's what most engineer students do. So 7.8. So you are going to add 7.8 to the center. Are you going to add it to the X or to the Y center? Well, that depends on if you're up or down, left or right. So if I'm up and down, what do you think I would add 7.8 to? The X or to the Y? If you're up and down, yeah, you can add it to the Y. Okay, so add 7.8 to negative 4, and you would be at 3.8. And subtract 7.8 to 4, and you're at negative 11.8. So these are your foci. Those are your vertices. So let's kind of graph that just to see that we're right. Here's 2, 1, and we go to 3.8, which would be like 2, right about here, 3.8. There's a foci. And then 11, and unfortunately goes off my grid because this is a 10, 11.8, negative 11.8 right down here. And there are the foci. All right. Last thing I need to see, this is brand new, and this is the last final thing, is something called the asymptote equations. I need these equations. How do you write an equation of a line? There's two ways. You can actually find 2 points, find the slope, put it into point slope form. That's fun. I mean, here's a point, and then obviously the corner of the box is a point. But I'm going to show you a trick. Okay, so here's the trick. Asymptote equation. You are going to, and it always works out this way because it's pretty cool for hyperbolas. You're going to take this fraction. You're going to set it equal to this fraction. Don't worry about the 1. Don't worry about the minus. Like almost put an equal sign right there and then scratch out the 1. So you're going to rewrite y plus 4 squared over 25 equals x minus 2 squared. Don't worry about negatives or positive. Just put both of those fractions equal to each other. Okay? Now, solve this equation for y. Solve it for y. And you're like, I don't know how to do it. Crisscross multiply. Crisscross. Multiply by 25 on both sides. So you would get y plus 4 squared equals, I'm going to put the 25 in front, over 36 times x minus 2 squared. Okay? Now again, we're solving for y. Take a square root, both sides. The square and the square root cancel. I'm running out of room, so I'll move it up here. So I have y plus 4 left on my left side equals, what's the square root of 25, 36? What's the square root of 25? 5. What's the square root of 36? 6. What's the square root of x minus 2 squared? X minus 2. But don't forget, there should be a plus and a minus. Oops. And now you just distribute. So you would have, or actually you can bring the 4 over. Y equals negative 4 plus or minus 5, 6, x minus 2. And I would actually let you leave it right there. You could, obviously, again, distribute the 5, 6 to each of these and then combine with the negative 4, and you'll get your one equation with a positive slope, then you'll get the one with a negative slope. But I'm really fine with you just stopping right there. But it's really easy. Just set the two fractions equal together, solve for y. All right, so hopefully that was not too hard. I mean, if you did the ellipses pretty good, this shouldn't be too hard. Let's do one more. Graph and label. 9x squared minus 4y squared minus 54x minus 40y minus 55. Now, I know this is already a hyperbola. Here's why. It's an x squared and a y squared, which means it's not a parabola. How do I know it's not an ellipse or a circle? These two have to be the same. In terms of, for an ellipse, it would have to be, these two would have to be positive, but one of them is negative, so that makes it a hyperbola. All right, so we have to complete the square. Let's go over how to do that real quick. Keep your x squareds and x term on the one side. and put plus blank. Then write your y squared minus 4y squared minus 40y plus blank, and bring the number to the other side, change its sign, and put plus blank plus blank. Now you got to factor out the 9 from this one. And since this is leading with a negative, you're going to factor out a negative 4. That would be y squared plus 10y plus blank equals 55 plus blank plus blank. All right, now we're going to complete the square part. Half it and then square it. Half of negative 6 is 3. 3 squared is 9. Do I put 9 over here? No. I put 81. Half of 10 squared, half of 10 is 5. 5 squared is 25. Do I put 25 over here? No. I put negative 4 times 25, which is negative 100. Then I rewrite this. Remember, this is a perfect square trinomial that can be factored into x minus 3 squared. Keep the 9 on the outside. This is a perfect square trinomial that can be factored into y plus 5 squared. 5 times 5 is 25. That's where. Put the minus 4 here. And then 55 plus 81 and negative 100 make 36. And then to be a hyperbola, you have to divide and set it equal to 1. So let's divide 36. And these should reduce. So it's x minus 3 squared over 4 minus y plus 5 squared over 9 equals 1. So we are now going to graph this and label all the parts. Okay, if you want to stop and graph it yourself right now, you can. Okay. So let's start with what's my center? Center HK. So change the sign. 3, negative 5. I'm just going to graph that right now. 1, 2, 3, negative 5. Okay. And then I just make my box. I go, if I'm under the x, I go the square root of 4, which is 2, left and right, because I'm under the x. X always goes left, right. So I'm going to go not 4, I'm going to go the square root of 4. 2, 1, 2 this way. If I'm under the y, I go the square root of 9. 1, 2, 3, 1, 2, 3. Draw a box, draw a box, draw a box, draw a box. Draw in your asymptotes, which we'll find the equations in a minute. Asymptote, asymptote, asymptote. Okay, now determine, is it up, down, left, right? And again, that is based off of which one is positive. The x comes first, it's positive, so you are going to go left and right. So you are going to go as wide as those asymptotes, touch that vertice right there, and go away. And the same thing to the other side, because hyperbolas are mirrors. So we need to find those 2 points. Those are the vertices. These are just help us draw the box. These are the vertices I want you to find. So those vertices are at 5, negative 5. And this one is at 1, negative 5. The foci, c squared equals a squared plus b squared. So 4 and 9 is 13. Take the square root of that. It's about 3.6. Do you add 3.6 to the 3 or 3.6 to the negative 5? The x is positive. Add it to the 3. Okay, so your foci are going to be at 6.6, negative 5, and negative 0.6, negative 5. Again, you could put it just as 3 plus square root of 13 or 3 minus square root of 13. I'm just doing it the way most engineers would do it. And then, last but not least, let's find those asymptote equations. These are all the parts that I want you to do on homework tonight. Okay, so very easy. Take this fraction, set it equal to this fraction. X minus 3 squared over 4 equals y plus 5 squared over 9. Don't need anything with signs. crisscross multiply and solve for y. So the 9 would go over here. So you'd have 9/4 x minus 3 squared equals y plus 5 squared. Take a square root. The square root and the square cancel. I'm going to flip this to the other side. Square root of 9 is 3. Square root of 4 is 2. And the square root of x minus 3 squared is x minus 3. Stick a plus or a minus and bring the 5 in front and change its sign. -5 plus or minus 3 over 2 times x minus 3. There you go. Those are the asymptote equations. Sorry for the length of this, but hopefully it made some sense. Try your homework. Have a good night. Bye.